Okay, and here we are on stage with Moritz Duge, Senior Development Relation Lead at Allotropia Software. He will give us a presentation about LibreOffice and JavaScript, and the floor is yours. Have a nice presentation.
Thank you very much. Welcome to my presentation about running LibreOffice in the browser and interacting with JavaScript. So let's get to the next slide. What can I tell about Office suites in general? So you probably use a lot of Office suites when you write a document. So I don't know, writing my bachelor thesis was a pretty big document I did in LibreOffice. But actually, there are a lot of people and organizations who use Office suites actually more like a tool. They have application frameworks developed around Office suites. So they have specific business applications where they do stuff like contract renewal for customers or public administration, giving out stuff to citizens like a fishing license or something like that. And they like to build those applications around an Office suite. Because Office suites just give you a lot of powerful features, and they are basically a low-code platform for employees working in companies having no IT background. So they can do pretty powerful things when they use an Office suite, because you have powerful features like charts, which you can get up in your spreadsheets, and you can do nice things with macros with just a little bit of source code, but not too much programming knowledge. And that's why companies like to do things with Office suites to realize workflows. And so what's the problem here? The problem is more and more stuff is being migrated to the web, which is basically a nice thing because it gets you free of the operating system. But you have the problem that you can't program web Office suites in the way you could do it with desktop Office suites before. There are some things like Google Cloud APIs, but it sticks you even more closer to a vendor than when you did that before with a proprietary desktop Office suite. So what can we do here? And the solution I like to show you is to run LibreOffice in your browser. What's already possible since a few years actually is to run LibreOffice on a server and to stream the result to the browser front end. But what I like to show you is to run it actually inside your browser. So a small timeline. In 2021, my colleagues presented LibreOffice running inside the browser using WebAssembly. We call that LOVA, LibreOffice WebAssembly. And WebAssembly is basically a way to compile native applications written in C++, for example, to a standard which is accepted by all browsers, like JavaScript is, so it can run inside the browser. But at that time, it was really just the encapsulated application running inside the browser. You couldn't really interact with the web world happening outside that capsule inside the browser. So that's what I'd like to show you today. We have put a lot of work into a wrapper we call Zeta.js, which enables us to interact from JavaScript with the Office software running inside the browser, exchanging data, and doing interesting things. So the Zeta.js wrapper we developed is providing a JavaScript interface which you can use in a pretty natural way for JavaScript to interact with LibreOffice. LibreOffice on the desktop already has a very powerful API. It's the API, and Zeta.js is allowing the JavaScript in the browser to access this API and to control the LibreOffice running inside the browser. You don't need any complicated web server. The web server can be pretty small. You can use a Raspberry Pi or something like that. It just needs to serve a few static files, currently 32 megabytes of size, and a smaller file with some data like textures. So that's pretty nice. It's another advantage over what you can see right now when you're, for example, running some Office in your Nextcloud. Then most of the stuff runs on the server. You need pretty big servers for that, and you won't need that here. And we have some ongoing work. We'll probably find some ways to cut off parts of LibreOffice so we get the size even down more. So that's a pretty performant way to run LibreOffice. A small digression about JavaScript. I don't know how much you know about JavaScript. So usually when you run JavaScript inside the browser, you do it in some context which is usually called the main thread. So thread is not really a good term for this, but I'll stick to that because it's what you usually find when you're reading about this. And when you run code in parallel in your browser, there is a feature by the browsers which is called web workers. So it's more like processes actually which are being realized inside your browser. So for each web worker, there's another JavaScript virtual machine running inside your browser. And when you want to exchange data between those web workers, you can do it via a message passing mechanism, or when you want to exchange large amounts of data, you need something called a shared array buffer. So I'll return to that later because there are some problems connected with that, but that's basically the foundation we need to run LibreOffice in a performant way inside the browser, because surely LibreOffice is a multi-threaded application, and so we need multiple control flows to adapt this inside the browser. Now I have a nice video, which is kind of a live demo, but live demo I can't do here, so I have the video, there's the video. So here you see actually a frame inside the browser. It's a canvas where LibreOffice is running. And the first thing I do here is just doing standard Office stuff, like selecting text, making it bold, changing the formatting. That's pretty straightforward Office things you can do. So we're using some browser controls to control this. So there you see a first interaction between the browser and LibreOffice. And what we are now doing is we are actually using data we are getting from JavaScript and inserting that inside as a document. So we have a great way to interact here between JavaScript and the LibreOffice software running there. And you can use like existing customer databases or anything you have in your web application to put that automatically into documents you get loaded through LibreOffice. Another thing I show you here is how this is being done actually by JavaScript. So here's a small browser console opened at the bottom. And there you can see I'm actually now searching for the term lorem ipsum. And now there's a search descriptor. And in the next thing you'll see, okay, I say for the search result there, insert another string. And no, there's Hitchhiker's Guide inserted in the first line of the text. So that's kind of the way how it feels when you program LibreOffice through this JavaScript interface. Another thing you can do is actually control big parts of LibreOffice, like hide the toolbars or get them back. So for example, here I showed the menu bar, which is usually being hidden for this scenario. So this is all nice stuff you can do actually through this interface from JavaScript. Maybe in the video you already realized that at the top there was a download button, so you can download a PDF file from the document after you prepared it in the browser, so you can download it. And I'd like to talk a little bit about how this works. So first thing is we have some initialization where we get some basic objects. So this is if you have done UNO programming for LibreOffice before, accessing LibreOffice on the desktop through its API. So these are very common objects you'd use for that, and you get them here from the Zeta.js API. And so this is something happening inside the web worker, which has the context for the LibreOffice process. So when you debug this inside the browser, usually you have to ensure when you're in the debug tab of the browser that you select the right web worker. It's a not so well-known feature because many web applications don't use multi-threading yet. But in this case, you need to select the right web worker. So next thing we do in this web worker context here is we have the document object we get from Zeta.js. And we can simply instruct LibreOffice through this document object to store it to some place in a virtual file system. We actually use a tool here, it's called mscripten, to build this WebAssembly environment for LibreOffice. And WebScripten is providing some kind of virtual file system. And we can instruct LibreOffice to write the file we just saw onto this virtual file system. And then there we have a PDF file. The next thing, this is now actually happening in the main browser thread. First thing we do is read the file from this virtual file system. So there is this fs object at the top, which is actually being provided by the mscripten framework. And from there we get the file, and now we have a kind of byte array, and then the rest is pretty much standard JavaScript, where we create a virtual object, and then we provide a download for that, and the user gets a pop-up where he likes to save the PDF file. Yeah, so the nice thing is you can do very different things with Zeta.js. What I just showed you is like you insert some address data into a letter, but actually you can do everything you could do when you program LibreOffice on a desktop and use it through its API. So here, for example, is a screenshot of another scenario where we are using a spreadsheet document to display some data points. For example, here there is a browser application which is pinging other websites and is measuring the latency to other websites, and then this data is being inserted into the spreadsheet, and you can do everything you can usually do in a spreadsheet, like put up a nice chart to animate those values. And the document itself, it's just created in LibreOffice. I put up another window beside that where you see where I just created that document, and you put it into your web application, and then you have there this document displaying the data it gets from the JavaScript interface. Yeah, so you may have a look at our website. We have a few other examples there where we play around with that. I have some nice stuff where I show, I have put some nice stuff up where I show how to register to events in LibreOffice. That's another thing you usually like to do when you access this UNO API. Usually what people do when they do this in a desktop or server environment, but now you're also able to do this inside the browser. And we have some pre-compiled binaries for LibreOffice built for WebAssembly. It's usually not the first thing you like to do when you start playing around with this, because it's some work involved to compile this yourself, although it's possible. You can definitely do this from the LibreOffice sources. Yeah. I have a little more information about the challenges we had. There's not much time left, so I will cut this a little bit short. So there's pretty much cutting-edge technology involved. WebAssembly is still pretty young. The mscripten framework I mentioned before is still pretty young. And yeah, also this web worker stuff. One thing we encountered, which is really a problem, is you maybe heard about those CPU bugs a few years ago, Spectre and Meltdown, and I was really making big eyes when I read the first time that this is somehow interacting with this WebAssembly inside the browser. But turns out the browser does some kind of memory isolation between its JavaScript virtual machines, and this breaks when you run high-performance code inside the browser, or it does not break, but you can actually exploit Spectre and Meltdown then from inside the browser, and you can't exploit the host, but you can exploit like data from other websites being loaded inside the browser at the same time. So there's a challenge in that, and maybe look for the term CORS, C-O-R-S, if you like to know more about that. That's definitely a challenge in this field. But yeah, browser vendors are onto this, and it's making progress. So some future plans we have, we want to improve the integration with some web frameworks. We already have a small example how to do the whole thing inside a Vue.js application. We want to add type information for TypeScript, so that's a nice thing we can do because we have a lot of type information from C++. Further strip down the binary size and doing some more debug builds and so on. Yeah, that's basically it. Thanks.